Hey guys, what's up? I hope all of you are doing very well. Okay, so in this video session, we will discuss briefly about electric dipole and its properties. This topic is too much related to chemistry also. So if you will understand the topic here very well in physics, it will also help you and guide you to visualize the concepts of chemistry very well. Because in chemistry, a brief will be given there, okay, related to theoretical as well as numerical. Okay, about electric dipole, the question every year comes in NEET exam and G exam of at least 2 marks. Okay, so let us begin our today's session. But before we begin our today's session, please subscribe my YouTube channel Pratik Singh Classes. Do like and share the channel Pratik Singh Classes among your friends so that everybody can get benefit from my knowledge, and please hit the bell icon so that whenever I will upload a new video you will get its notification. So voila, let us start our today's class. In our previous classes, we have studied about electric field and electric field lines, then their properties, then what are their significance, then the one most important question we have seen that two electric field lines never intersect each other. Okay, so if you have missed those things, please go to my previous video lectures. If you are unable to find my previous video lectures, at the top right corner, you are watching one I symbol there. If you click that I symbol, now you can see the topic of the related video lecture. Click on that and you can go to that video. Okay, so starting our today's class, today we will study about electric dipole and its properties. Okay, so this term electric dipole is new for you. Dipole you already have studied in class 11th. If you haven't, then we will do once again. Okay, this topic electric dipole, it is related to physics as well as chemistry. Okay, so listen very well, and I request all of you that while you are going through my video lectures, please keep a pen and notebook so that whenever you get something interesting, you can write it down then and there. Okay, fine. So first question is, what is electric dipole? See, di means two and pole means two adjacent or two different positions, okay, or two different phenomena. So two equal and opposite charges separated by a small distance constitute an electric dipole. Okay, so as the definition suggests, two equal and opposite charges. Okay, that means if suppose you have two charges, okay, one is positive charge and other one is negative charge. Okay, keeping in mind that their magnitude are same. Suppose positive charge is of x coulomb, then negative charge must be also of x coulomb. Okay, separated by a small distance. That means the distance from center of positive charge to center of negative charge, this distance will be very small. Then this total configuration makes an electric dipole. Now here question comes is, how much should be this distance? When we say separated by a small distance, then how much will be this distance? Keep in mind that the distance from charge to charge must be greater than the atomic radii of the given charges. Okay, so you have to keep in mind that the distance between the positive charge to negative charge must be far greater than the atomic radii of the atoms or of the charges in the dipole. Okay, so in that situation it makes a dipole. Okay, always keep in mind means that di means two and pole means polarity. Fine. In many molecules, the centers of positive and negative charges do not coincide. Okay, such molecules we have as permanent dipoles. Okay, we in your 11th class onwards in chemistry you have studied about Lewis dot structure, then Fisher projection structure, and a lot others. There you might have seen that the center of the charges, okay, are separated from each other. In that situation, those molecules make permanent dipoles. Okay, for example, carbon monoxide, water, ammonia, hydrochloric acid, etc. How does this happen? Okay, let me show you in another slide. So on your screen you can see here we have taken three molecules. Okay, first one is that of ammonia molecule. Okay, as you can see the first one. The second one is of HCl molecule, hydrochloric acid molecule, and this third and fourth are of water molecule, that is H2O. Okay, in the first molecule, that is of ammonia molecule, there are three atoms of hydrogen and one of nitrogen. Okay, here the nitrogen atom is lying at the top and the three hydrogen atoms are lying at the bottom. Suppose these three hydrogen atoms are touching the bottom surface, then the center of the electronegativity, okay, will lie somewhere at the center of the triangle made by these hydrogen atoms, and the center of electronegativity of nitrogen atom will lie above it. Okay, so that means there is a gap between the positive charge and negative charge, and so it makes a permanent dipole molecule. Coming to HCl molecule, as you can see from here, this white color lobe is of hydrogen atom and this green color lobe is of chlorine atom. The number of electrons on chlorine atom is far more than that of hydrogen atom, that is 1:17. You know very well from chemistry. Okay, because of that hydrogen here is slightly positive charge and chlorine here is because of slightly negative charge, and because of that there is a gap between the center of positive charge and the center of negative charge, and so it makes it a permanent dipole molecule. The same thing happens in the case of water molecule. As you can see on the screen that two hydrogen atoms are lying at the bottom and one oxygen atom is lying at the top. Okay, here because the electrons have shifted from oxygen atom to hydrogen atoms each one, okay, that means hydrogen becomes slightly electronegative and oxygen becomes slightly electropositive. Okay, just imagine somewhere between these two hydrogen atoms lies the center of negative charge and just above them lies the center of positive charge. That means there is a small gap between the center of positive charge and negative charge, so it makes water molecule a permanent dipole molecule. Likewise, same thing we have seen. Okay, so likewise same thing in fourth diagram. So I hope you have understood now very well what is the meaning of permanent dipole molecule. Okay, this topic dipole molarity, okay, or dipole structure, okay, will come in physics as well as in chemistry, more in chemistry, because a lot of other topics you have to study there, like what is permanent dipole molecule, okay, then how to convert and non-permanent dipole molecule to a permanent dipole molecule, then in what situation the molecule will lose its dipolarity. Okay, then a lot of other numerical sums also will come in chemistry. Okay, this topic is too much important for your NEET exam as well as JEE exam. Okay, keep in mind that every year in NEET exam or JEE exam at least a question of 2 marks comes related to this topic. Okay, and every year at least a question of 1 mark comes in board exams. Okay, so this topic is too much important. Now we will go to the next topic of our textbook. Alright, so consider two equal and opposite point charges. Let me pick up the pen here. Okay, that is plus q and minus q. They are separated by a distance 2a as shown in figure 1.16a. The electric dipole moment is defined as P, vector P. See, it is denoted here as a vector quantity. That means electric dipole moment is a vector. It will have magnitude as well as direction. What will be the direction of dipole? We will see later. Is equal to q into r plus minus q into r minus. Okay, here what is the meaning of q and what is the meaning of vector r? Where q is the magnitude of positive charge, okay, and or negative charge, and r is the distance vector from positive charge to negative charge. Here r plus vector is the position vector of plus q from the origin, and r minus is the position vector of minus q from the origin. Okay, see, whenever we say position vector, what does that mean in physics as well as in mathematics? Taking the reference of mathematics, coordinate geometry, okay, or vector algebra, suppose this is your x-axis and y-axis. Okay, take a vector starting from origin and goes anywhere. Okay, suppose at point P. Okay, so this is called as position vector. Okay, vector r. Keep in mind that there is a huge distance between vector r and r cap. R cap is not a vector. It shows a vector whose magnitude is 1 and direction in the direction of vector r. Always keep in mind. Okay, so I hope you understood this thing. What is the meaning of position vector? Okay, this topic might have come in class 11th mathematics earlier. Okay, so coming to your figure 1.16, what does it say? Let us see. Okay, so let us see what is given in figure 1.16 A and B. Okay, in figure A, you see here that we have two charges. Okay, one charge, that is positive charge, is lying on positive x-axis, and the negative charge minus q is lying on negative x-axis. Okay, and at here is the origin. From origin to positive charge we have the separation or the distance a, and from origin to negative charge we have separation a. That means from negative charge to positive charge total separation is 2a. Now this figure became too much blurry. Let us delete all the things to visualize it once again. Okay, on the screen you can see that this red color vector, that is vector p, is the direction of dipole moment. That means from negative charge towards positive charge. Okay, as given here. Okay, inward the dipole, the direction of dipole will be from negative to positive, and outward the dipole, it will be from the lines of electric field will be going from positive charge to negative charge. Okay, in our previous video section we have seen that from positive charge electric field lines goes outward, okay, up to infinity, and from negative charge electric field lines comes towards the charge from infinity. The same thing is here. Electric field lines are coming from positive charge and going towards negative charge, and in the center you can see here from minus q to plus q. So this is about dipole. Okay, dipole moment. To understand it very well, I have made another slide. Okay, let us go to that slide to visualize it very well. So what is dipole moment? Okay, the answer is dipole moment tell us on average where the electrons in a molecule are. Means if you have a molecule, then if we know what is the dipole moment, we can find out at which position in 3 dimensions of the molecule where is the higher density of electrons are. They can also tell us the shape of a molecule. Means if we know dipole moment, we can visualize very well what is the 3-dimensional arrangement of atoms in the molecule. Okay, in that situation it will help us to find out if the molecule will react with any other atom or molecule or an ion, how will it react, and what will be the you can say diagram of the new molecule. Okay, for instance, if suppose we take water molecule H2O, where linear, okay, means we have seen that H2O is of V shape like this. Okay, at the bottom there is oxygen and at the top 2 hydrogen atoms are there. Okay, the two oxygen hydrogen bond dipoles would cancel each other out and the whole molecule would be a non-polar. Okay, its formula is mathematical product of separation of the ends of dipole and the magnitude of the charges as given in the figure below. Okay, so dipole moment is shown or written in two ways. Either you write a small p with a vector notation or mu, the symbol mu, that is also the symbol of dipole moment. Okay, you can see here in the first figure that there is a positive charge q plus and a negative charge q minus. Keep in mind that whenever you will say about dipole moment, the charges at both the ends will be same in amount, in magnitude. Okay, and here the distance between the positive charge to negative charge is r. So here the dipole moment is equal to q into r, means taking the magnitude of any one of the charge into the distance between the charges, as we see in the second figure. Okay, here in second figure, negative charge and positive charge are separated by a distance d. Okay, and here dipole moment is equal to q into vector d, that is magnitude on any one of the charge multiplied by the distance between them. Okay, so I hope now you are well much understood with the meaning of dipole moment. Okay, so I have made this slide for you. Now coming back to our textbook, you can take the screenshot of my previous slide, and also at the end of the video session I will give one by one how the slides I have made. Okay, from there you can also pause and note down the important examples and definitions of the terms which I have provided. Okay, so coming back to our book, so here let me take the pen. So here dipole moment, okay, p is vector p is equal to q into a I cap minus q into a into minus I cap. Okay, here minus I cap has come because the charge here is lying on the negative x-axis. Okay, in actual the total dipole moment is equal to q into a is the distance from origin to the charge, one charge, plus this is q plus, okay, plus q minus into a. Okay, that means in the previous page we have seen that if suppose on x-axis we have two charges, okay, one positive charge on positive x-axis and one negative charge on negative x-axis. Okay, from origin to charge, positive charge, we have a distance a, and from origin to the negative charge we have distance a. Okay, so total dipole moment is equal to this one, this positive charge, magnitude of positive charge into the distance from origin, that is a, plus the magnitude of negative charge into the distance from the origin, that is again a. Okay, so here this positive sign has changed to minus q because the charge, magnitude of charge here is minus, so this became minus q, and again this a distance is in negative x-axis, so again this will become minus. So here equation 1.11 became qa I cap minus q into a into minus a minus I cap, so total it will become 2q into a I cap. Okay, as it suggests here that the magnitude of the dipole will be 2 into q into a, and the direction is I cap, positive I cap, that means from origin towards positive x-axis. Okay, so I hope you are totally well known of this topic. The electric dipole moment vector lies along the line joining two charges and is directed from negative charge to positive charge. Okay, if suppose you have charges on x-axis, positive x-axis, okay, and negative x-axis, then the dipole direction will be starting from negative towards the positive charge, okay, lying on the line joining the charges. The SI unit of dipole moment is coulomb meter. As you can visualize this from the equation 1.11 itself. Now this figure became too much rough, so let me erase something from here and show you how to get the SI unit of dipole moment once again. Okay, so it is clear now. Just a moment. I am using my system, okay, so that I can use all the tools. If I record this thing from mobile phone, it will not be easy for me to write on the screen or to do notations on the screen, okay. If you are using mobile phone, okay, you can see full screen because I have changed the settings in the ratio of 16:9 of the window screen. Okay, all right. Fine. Now coming to our topic, I was saying that here the SI unit of dipole moment is coulomb meter. Why it is coulomb meter? Because Q into A, okay, that P is equal to Q into A. So here Q is the amount of charge, so its unit will be coulomb C, and A is the distance between the charges, so its SI unit will be meter. So the SI unit of dipole is coulomb meter. So I hope you have understood this. Okay, coming to next topic. The electric field lines for an electric dipole are as shown in figure 1.16b. okay, this figure, that electric field lines are coming from positive charge and going inward the negative charge, as you can see from here, coming from positive charge and going inward negative charge. This is the direction of electric field lines, okay, but the direction of dipole is from negative to positive. Always keep in mind this difference. Okay, now let us come to our next topic. For simplicity, the two charges are placed on x-axis. In our previous figure 1.16a and b, we have seen that the charges were placed on one positive charge on positive x-axis and a negative charge minus q on negative x-axis. If suppose, even if two charges are placed on y-axis or z-axis, dipole moment will point from negative charge to positive charge. Okay, just visualize it that suppose you have two charges. Okay, suppose this is x-axis, this is y-axis, this is origin. Above we have plus y and we have below minus y. One charge is lying on positive y-axis. Suppose this is a positive charge, and the other charge is lying on negative y-axis. Even in that situation, the dipole moment will point from negative to positive charge. So keep in mind, okay, if suppose in another case we have EZ axis, okay, this is x, this is y, and this is EZ axis. Okay, so this will be the positive EZ axis and this will be your negative EZ axis. Suppose on positive EZ axis there is a positive charge plus q, and a negative z axis we have a negative charge minus q, and the separation between them is 2a. Then even in that situation, the magnitude of the dipole moment will be 2q into a. Okay, whenever we write 2q into a, in actual dipole moment P is equal to q, that is magnitude of charge, any one charge, into the distance, that is 2a, because here a is the distance from origin to that charge. Okay, so here even in this situation, total dipole will be equal to q into 2a, or you can say 2qa in magnitude, and the direction of the dipole will lie from negative z axis to positive z axis. Always keep in mind. Okay, but if you visualize the direction of electric field lines, in that situation the lines will go from positive axis to negative charge. Okay, positive charge to negative charge, so keep in mind that thing. Okay, now coming to next point, but before coming to next point, let me erase all those things. Okay. Okay, all right. Though the electric dipole moment for two equal and opposite charges is defined, it is very general. Okay, it is possible to define the electric dipole moment and calculate the electric dipole moment for a single charge also. Means even if there is only one charge, you can find out what will be the electric dipole because of that charge at any particular distance. Then two positive charges also we can find out. In dipole moment earlier we have seen that we take either a positive charge and a negative charge separated by a small distance. Okay, but even if suppose at two places we have positive charges, even in that situation we can calculate how much it will be. Okay, then we can also find dipole moment because of negative charges for even two charges or more than two charges. Okay, about superposition principle we have seen earlier. If suppose you have missed the superposition principle video, you at the top of your right corner of the screen you can see I symbol there. Okay, from there if you click you can get that video also. Okay, I symbol is there at the top. From there if you click, okay, you will see that video also. Okay, fine. Now coming for a collection of n point charges, the electric dipole moment is defined as follows. That means if suppose in a system we have a lot of charges, whether positive charge, negative charge, or combination of both, in that situation total dipole moment can be calculated by this formula. Okay, the formula is electric dipole vector P is equal to sigma qi into vector ri, where I is equal to 1 to n. Okay, so this is the electric dipole moment for a system of charges. Okay, in general what does this equation 1.12 mean? Okay, let me show you in the slide. Okay, so this is the explanation of the equation, that is dipole moment vector P is equal to sigma pi into vector ri, where I is from 1 to n. That means q1 into vector r1 plus q2 into vector r2 plus q3 into vector r3 up to qn into vector rn. So this is the complete explanation. Okay, by this formula you can find out if suppose there are n charges in the system, then what will be the total electric dipole of the system. Fine, so this is the explanation of the equation given earlier. I hope now you are very well understood how to find total electric dipole if n number of charges are given. Okay, in this equation you can use either positive charge or negative charge. If suppose you have positive charge, then wherever you have q you have to give positive symbol. Okay, and whenever you have a negative charge, so at the place of q substitute minus symbol also. Okay, again if suppose the charge is lying on positive x-axis or y-axis or z-axis, in that situation the r1 r2 r3 all those will be positive. But if suppose the charges are lying towards negative of the axis, that means in negative x-axis or negative y-axis or negative z-axis, in that situation you have to substitute negative sign also with that. Please keep in mind, this is the confusion when students try to solve the numerical sums. Okay, so now coming to our next topic. Okay, so a very important topic is here. Okay, the electric dipole moment depends on the choice of origin and charge configuration. Okay, this may be asked in 1 mark question. Always keep in mind that dipole moment depends on choice of origin. Okay, means it may be possible that if you change the origin, the symbol of total electric dipole will change. It may become positive to negative or negative to positive by changing the orientation on the axis. Okay, about orientation of axis, you might have studied in physics standard 11th volume 1 in second unit. Okay, if you haven't, please go to that book. Fine. So this is the end of today's class. Okay, now I am providing you the slides one by one which I have taken, so that you can pause the slides and take the readings one by one. Okay, so let us begin the slides. Summing up to our today's class, this is the first slide which I have shown you. Okay, this was about to visualize how is the electric dipole to find out. Okay, and what is the meaning of permanent electric dipole and permanent dipole molecules. Okay. Okay, so this is the second slide which I have made for you. Okay, in this slide I have shown what is the meaning of dipole moment. Okay, then what is the formula, then how to find out the dipole moment. And the bottom I have written here, in previous class you have studied about moment and momentum. Okay, so related to this, how you can get help to visualize the electric dipole moment, you can understand very well. Okay, so and this was the third slide, last slide, where we have tried to find out what is the total electric dipole moment when we have a system of n charges, whether the charges are positive or negative or a combination of positive and negative charges. Okay, so I hope you have understood our today's class very well. All right, so I hope that you might have understood a new topic which you have seen today. I request all of you that if you have any doubt related to this video, please write the doubts in the comment section below in the YouTube channel. Okay, I request all of you to share my channel as much as possible among your friends and others, so that everybody can get benefit from my knowledge. Okay, if there is any mistakes in this video, or if you want something new to be added in my video, you can write about that in the comment section also. So please subscribe my channel, okay, and like and share as much as possible, and hit the bell icon so that whenever I will upload a new video, you will get its notification. Okay, I hope all of you are doing very well, all of you and your family are healthy. Stay safe. Till then, bye bye.